So in this video in chapter 7 IP addressing, I'm gonna discuss to you the summary of chapter 7. So first IP addressing. So addressing is a critical function of network layer protocol. So addressing enables data communications between hosts regardless of whether the hosts are on the same network or on the different networks. Both internet protocol versions IPv4 and the Internet Protocol's version 6 of IPv6 provide hierarchical addressings of packets that carry data. So, designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficient. So, this character examines the data of structures of IP addresses and the application to the construction of testing of IP address and subnetworks. So we have positional notation. So we have positional notation first. We have radix. So the radix is now identify numbers based on the radix. The decimal system notation based on 10. Therefore, the radix is 10. So we have positional number. So the second row considers the positional of decimal numbers starting from the left, 0, first position, and the second we have position, and the second of the third positions, and the third of fourth position. These numbers also represents the value will be used calculate the positional value of fourth row. So we have to calculate. So we have calculate like example have 10 raised to 1 or 10 raised to 2. This is what I calculate of positional notation. The third row calculate the positional value by taking radix and raising by exponentials at each positions. So note that r raised to 0 is always to 1. So positional value, we have the first row identifies the numbers of radix. Therefore, the values listed left to right represents units of thousand, hundred, tens, and ones. So we need for IPv6. So the device can be assigned for IP addresses either statically or dynamically. So in a network, sometimes device requires fixed IP addresses, for instance, printers, servers, and networks devices. So need an IP address does not change, and for this reason, this device are typically assigned static IP address. So a host can be configured with a static IPv4 addresses, such as assigning host static IP addresses is acceptable. In a small networks, however, it would be time consuming to enter static addresses on each host in a large networks. It is important to maintain an accurate list of static IP addresses assigned to each devices. So IPv6 is designed to the successor of IPv4. IPv6 has a larger 128-bit address space, so providing for 340 zillion addresses. That is the number of 340 followed by 36 zeros. However, IPv6 is more than just a larger addresses. When IETF began its development of successors of IPv4, it used the opportunity to fix the limitation of IPv4 and include additional enhancements. One example, Internet Control Message Protocols. So, the need of IPv6 is depletions of IPv4 address space has been motivating factors that moving of IPv6 as the Asia's other areas of the world become connected to the internet. There are not enough IPv4 addresses to accommodate this growth. So IPv4 is a theoretical maximum of 4.3 billion addresses Private addresses is combination of network addresses. Transition of NAT have been instrumental showing the depletions of IPv6 addresses space. And however, NAT uh, breaks the many applications and has limitations that severely impede peer-to-peer communication. So internet of everything. So yeah, and the internet is today is significantly different than the internet the past decades. So the internet today is more emails, web page, file transmitting between computers, and the evolving of internet between the computers. So the evolving of internet is becoming uh, internet of things. So no longer will only devices accessing the internet be computers, tablets, and smartphones. So the sensors equipped with internet-ready device of tomorrow will be included everything for automobiles, and with the increasing of internet, so populations limited of IPv4 space issue with NAT, so and internet everything's the times come to begin transition of IPv4. So we have the omits leading zero. So this omitting leading zero, they have a activity in these chapters that we can answer. So it's, for example, we have a 1 AB, so can be represented as 1 AB because we emitting 0 uh, in the first 0, so we have 1 AB to represent to 1 AB. So we have 9F0 can be represented to 9F0. So we are always emitting 0 on the first number. So A 0A.00 will represent of A00. So 00AB can be represented to AB. Now we have the ICMBv4 and ICMBv6. So although IP is only a best effort protocol, so the TCP and IP suite thus provides for message to be sent in the event of certain errors. So these messages are sent using the service of INCP. So the purpose of this message is to provide feedback about issues and related to the processing of IP packets. So INCP, so INCPv4 is message are not required, are often not allowed within a network security reasons. So INCP is available in both IPv4, PV4 and IPv6. So these messaging protocols for IPv4 and IPv6 provide the same service of IPv6 but include additional functionality in this course. So INCP will be used when referring both INCP and IPv6. So there are types of INCP messages and reasons why they are sent are existent will be discussed as some of more common messages. We have in chapter 7 of summary. So they have a IP addressing in hierarchical network subnet, and host position of IP address can represent complete network as specific host of broadcast. And we have the subnet mask of prefix determine the network portion of IP address. So the prefix is when all the number ones will count, then will be your prefix. So can be designed either statically or dynamically. So DHCP enables automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration informations. So IPv4 hosts can communicate three different ways. They have a unicast, broadcast, multicast, also blocks of addresses that are used of networks requires limited no internet access called provide private addresses. So depletions of IPv4 address space is the motivating factors of moving uh, to IPv6 to IPv6. Each IPv6 address has 128-bit versus of 32 bits in IPv4 addresses. IPv4 does not use the dotted decimal subnet mask notations. The prefix length is used to indicate the network versions of IPv6 using the following formats of address and the prefix length. So they have three types of IP addresses. So we have unicast, multicast, and anycast. So IPv6 link local address enables the device to communicate with the other IPv6 devices on the same link and only in that link of subnet. Packets with a source of destination link local. So address can be routed beyond link from which packet originated of IPv6 local address in FE80 of the range. So we have a uh, you will identify that in packet activity in this chapter. So INCP available both IPv6 like what I discussed. So ICMPv4 is the messaging protocols of IPv4, and IPv6 provide the same service of IPv6 but include additional functionality. So after this implemented, IP network needs to be tested, verify connectivity, operational performance. So this is all about in chapter 7 of network of IP addressings and IP addressings of chapter 7, and that's all. Thank you.